Hello everyone, my name is Priyanka and I welcome you all to Study Room. So today we'll be studying chapter 9 of class 9 science, that is force and laws of motion. So let's get started. So have you ever wondered how much force is required to lift off a rocket? Did you ever try to know what is force and what are its effects? Well, let's explore all this together in this chapter. So, history and causes of motion. So, the problem of motion and its causes had puzzled scientists and philosophers. A ball on the ground, when given a small hint, does not move forever. Such observations suggest that rest is the natural state of an object. This remained the belief until Galileo Galilei and Isaac Newton developed an entirely different approach to understand motion. So, our Galileo Galilei Sir Isaac Newton developed an entirely different approach to understand motion. So, let's explore day-to-day illustrations of change in states of objects. So, in our daily lives, we encounter many situations wherein we exert muscular effort and say that we push or hit or pull an object to change its state of motion. For example, this person is moving this cart, right? It is bringing this cart to motion. This boy is hitting the ball, you're pulling the drawer, right? All these are examples of motion. Correct. So, what is force? Force is a push or pull upon an object resulting from an interaction of one object with another. For example, this is you and this is your friend, maybe classmate, and he is, giving you the push. He's pushing you forward. So, what is this? This is a kind of force. So we always see or feel the effect of a force. It can only be explained by describing what happens when a force is applied to an object. For example, this is a block of say 10 Newton and you're applying 11 Newton force from this side. So this block will move, correct? Because you're applying a force which is greater than the weight of the object. Okay. So effects of force. A force can be used to change the magnitude or velocity of the object, to change the direction of motion, and to change the shape and size of objects. So, what are the effects of force? Effects of force. Point number 1, change in magnitude of velocity. Point number 2, change in direction of motion. Point number 3, change in shape and size of objects. For example, in this case, these people are playing with the football, right? So there is a change in magnitude of velocity as well as direction. The direction of the ball is changing continuously. For example, a person is, playing with a sponge and changing its shape with force, applying force from this side and this side. For example, this spring, right? Change in shape and size when we compress it or we elongate it. Okay. So this is how we study the effects of force. So types of forces. So we need to study about two forces, balanced forces and unbalanced forces. So what are balanced forces? As the name suggests, forces which are balanced forces, right? For example, if 10 Newton is kept here and 10 Newton is kept here, right, on a way balance, then what will be the position? It will be linear, it will be straight line, right? There is no, heavy weight on like one side, right? So it's like equal weight. Balanced weights are equal, right? Balanced weights are equal. And when we talk about unbalanced weights, for example, can you see which one is the heavier? So it has two pieces, right? And it has just one piece. Right? For instance, this is 5 kg and this is also 5 kg. And this is extra 2 kg. So which one is heavier? This one is heavier. That's why your weight balance is dominated towards your right side. Correct? So these are unbalanced forces. So what does that mean? That in unbalanced forces, forces are unequal, unbalanced, right? As the name suggests. So balanced forces. If the block is pulled from both the sides with equal forces, the block will not move. For example, there is this 10 Newton block which is kept on a table. So you are, pushing it with a force of 5 Newton. Your friend is pushing it with a force of 5 Newton. What will happen to the block? It will not move. Correct? Simply because equal forces are applied from both the sides. And let's take some other example. For example, the 10 Newton block, you are pulling it this time. Here you were pushing the block. In this direction, you will be pulling the block with let's say 5 Newton only. And your friend is also pulling the block with 5 Newton. What will happen? There will be no change in the state of the block. So it will not move. So what does that mean? This means that such forces are called balanced forces and do not change the state of rest or motion of an object. So here we have seen the condition of rest. And what will happen in the condition of motion? Let's see that also. For example, a block is in motion. Correct? For example, this is a block. Let's say it's a 10 Newton block. And it is already moving with the speed of 5 meters per second. Okay. So if you applied, for instance, applied a force of 11 Newton on this block. Since you have applied a force which is greater than the weight of the object, it will change its speed. Correct? So, but if you apply 10 Newton only, or less than 10 Newton or 9 Newton, let's say, so block will continue to stay in the in the direction and with the same speed with which it is going. Okay. So hence we conclude that what are balanced forces? The forces which do not change the state of rest or motion of an object. Okay. So let's move forward. So unbalanced forces are completely the opposite, which change the direction or change the magnitude of force. Correct? Because unequal forces are acting in this case. So if two opposite forces of different magnitudes pull the block would begin to move. Correct? Right, in the direction of the greater force. For example, you have this block, let's say 5 Newton block. Okay. And you are pushing it in right direction with a force of, let's say, 10 Newton. And your friend is pushing the same block with the force of 12 Newton. Now what will happen? Since you can see that the force which is applied by your friend is like 2 Newton greater than yours, right? So this block will move in the left. Your friend is pushing it in the left direction. So this block will move in the left direction with a magnitude of 2 Newton. Why so? Because your 10 Newton will balance your friend's 10 Newton, and how much force is the remainder? 2 Newton. Correct? So it will move in the left direction with 2 Newton. So these are the examples of, this is an example of unbalanced force. Let's see one more condition. For example, you have one block, let's say 10 Newton block, and what is happening is that your friend is trying to push and this block is already moving with a speed of 5 meters per second. And your friend is trying to push the block, okay, let's say with a force of 12 Newton. Now you can see that, the weight of your block is 10 kgs, okay. So, right. And your friend is applying, for example, your weight of the block is 10 Newton, right? And your friend is applying 12 Newton to it. What will happen? The block will start to accelerate. There will be a change in velocity. Why so? Because of the unbalanced force. Correct? So, if two opposite forces of different magnitude pull the block would begin to move in the direction of the greater force. Thus, the two forces are not balanced and the unbalanced force acts in the direction the block moves. This suggests that an unbalanced force acting on an object brings it in motion. So, let's do some examples of unbalanced forces. For example, if a box is pushed with a small force, the box does not move because of friction acting in a direction opposite to the push. So, firstly, let's study what is friction. You know what is friction? It is a force which is opposing your force. That means you have to apply more force, right, to overcome this friction. Whenever you apply force, there's always a force which is acting in opposite direction. To resist your force. Okay, so there is always one force which is acting in the opposite direction. So if the box, so I'll give you this example. Okay, there is this box. Let's say it's a box of 10 kg. Okay, you're applying force. You're doing a lot of hard work and you're applying force, and you see that the block is not moving. Block does not move because you applied, very small force. Let's say, firstly, you applied a very small force, and you see that the block does not move. Why so? Why? Because whenever you apply force, right, your force in this direction, there is one force of friction which is opposite to your direction in the left. For example, your force is in the right direction, so friction is acting on the left direction, and friction is saying that, okay, you wanna move this block, first fight me, okay, fight with me. So this friction is acting in the left direction. Okay, it is opposing your force. So if your force is less than your frictional force, this block won't move, right? So if you're applying a very small force, your block won't move. Then comes the second case. Okay, for example, in the second case, what happens? You are very strong and you are like, I won't give up. In the second case, you applied some more force. Like earlier, it was very small force, so you applied force which here the friction was in the opposite direction. You applied force which was equal to the frictional force. So as we studied in the balanced forces that if 5 Newton applied from here and 5 Newton applied from here, what will happen? The block will not move. Why so? Because these are balanced forces. Now if your force is equal to the frictional force, what will happen? It will balance out. It will be a balanced force, right? So what do you think? Will this block move? No, it will not move now also. Why so? Because your force is just equal to your friction. Now you're like, oh, I just want to move this block. What will you do next? So simply you have to apply force which is greater than your frictional force. To move the block, if your force becomes greater than your frictional force, what will happen in this case? What will happen? For example, your friction is suppose 5 Newton and you're applying now suppose 6 Newton or 5.1 Newton also. If you're applying, what will happen? The block will start moving. Because now, why so? Because now you have overcome the frictional force. This opposing force, you just overcome this opposing force. Okay. So we have seen 3 cases. Case 1, when your force is less than frictional force. Case 2, when your force is equal to frictional force, which is your balanced force. And case 3, when your force is greater than your frictional force. Okay. So when your force is greater than frictional force, which kind of force is this? This is an unbalanced force, right? Because there are unequal forces. That is why there is movement, right? So these are the 3 cases, right? Finally, you move the block. So impact of unbalanced forces. So an object moves with a uniform velocity when the forces acting on the object are balanced and there is no net external force on it. These are the balanced forces, right? Balanced force. Same thing. For example, an object is moving with 5 meters per second and you apply 5 Newton from here and someone applies 5 Newton from here on the moving block. What will happen? The block will not move. Why so? The block will continue with the velocity with which it was moving because equal forces balance each other, right? But if an unbalanced force is applied on the object, there will be a change either in its speed or in the direction of the motion, as we saw that if on a block, for example, 5 Newton from here, 10 Newton from here, since this is the greater force and it is applied in this direction, the block will begin to move in this direction with the force of 5 Newton, because 5 Newton neutralizes the 5 Newton from this side. Left is your 5 Newton mode, because 5 plus 5 is 10, right? So it will move in left direction, right? So unbalanced forces can change the speed or the direction of the motion. And thus, to accelerate the motion of an object, what was acceleration? Change in velocity, correct? So to bring the change in velocity of the object, an unbalanced force is required, right? Balanced forces will cancel out each other, right? They will be equal. Unbalanced forces are required. Okay. So, and the change in its speed would continue as long as this unbalanced force is applied. However, if this force is removed completely, the object would continue to move with the velocity it has acquired till then, right? For example, when external force gets removed, for example, this block moving with 5 meters per second, okay, and your external forces, you remove both of them, so it will continue moving with 5 meters per second, okay. So how do accidents occur? So have you been a victim of accidents? I hope that it hadn't happened, but let's see. So if you crash your car into something, your body will resist the change in motion, and unless something else stops it first, correct? So have you seen that, whenever like your car is in motion, okay, your car is moving and it gets crashed, what happens that the person who is sitting in the car and suddenly the car is in motion, for example, the car is going this side, and suddenly it gets crashed in a tree, let's say, okay, what will happen? That the car was trying to be in motion and your body was also in motion with the car, and suddenly brakes are applied, like very shakily, right? You got shaked. You see that, you just, you also, get crashed. You also get forward. Why so? Because your body tends to be in motion. So, there is a very good thing of our body. We call it inertia. What is inertia? Inertia is a tendency to be in rest if you are at rest, and tendency to remain moving if you are moving. So your body will crash into the object at the same speed that the car crashed into the object. Why? Because your body was also in motion. When car was in motion, you were sitting in the car, your body was also in motion. And due to its inertia, your body tends to, crash. If when the car crashes, you also tend to move forward. Okay. So Galileo's experiment with inclined planes. Let's study these. Okay. By observing the motion of objects on inclined plane, Galileo deduced that objects move with a constant speed when no forces act on them. Okay. He observed that when a marble rolls down an inclined plane, its velocity increases because the marble falls under the unbalanced force of gravity. As it rolls down and attains a definite velocity, by the time it reaches the bottom, its velocity decreases when it climbs up. So let's quickly discuss about this. So, as we were talking about friction and opposing force, when we talk about, the force of gravitation, we're talking about the force of gravitation. It always acts in the downward direction, okay? It is in the favor of the earth, like, right, on the surface, right? So, you see that when a marble is rolled down an inclined plane, okay, so its velocity increases. Why? Because in the downward direction, gravity also acts in the downward direction, okay, and your ball is also trying to move in the downward direction. So what happens? That both the forces gets added. But in this condition, what is happening when you try to move the marble upwards? Okay, what happens? Your gravity is acting in the downward direction, and your ball wants to move in the upward direction, right? So these are like opposing forces, right? Correct. So if these are opposing forces, then what will happen? So your velocity will decrease because these forces are acting in opposite directions. Correct. These forces were acting in same direction. Gravity is also acting downwards and your ball also wants to go downwards. So your velocity increases. So this is why we see these results. So Galileo argued that when the marble is released from left, it would roll down the slope and go up to the opposite side to the same height from which it was released. So for example, your marble is released from left. Okay, this is your left direction. That means you're throwing the marble towards the downward direction. Gravity also acting in the downward direction. What will happen? The resultant velocity will increase. Once your ball reaches here and it goes up, this time again gravity always acts in the downward direction and your ball wants to go up, right? What will happen? That it will be an opposing forces, right? It will be opposing forces. So velocity of the ball will decrease. And if velocity will decrease, then of course it will keep on decreasing, right? Till the time it reaches the ground and it becomes flat, okay? So if the angle of inclination of the right side plane were gradually decreased, then the marble would travel further distances till it reaches the original height. So Galileo experiments, right? If the right side plane were ultimately made horizontal, its slope is equals to 0, right? The marble would continue to travel forever trying to reach the same height that it was released from. For example, if it was released from a height of 5 meters, so if it becomes straight, it will travel 5 meters before coming to rest. The unbalanced forces on the marble in this case are 0. It thus suggests that an unbalanced force is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. What are the results of Galileo's experiment? The presence of frictional force acting opposite to the direction of motion makes it impossible to attain zero unbalanced force. In practice, the marble stops after traveling some distance. The effect of frictional force may be minimized by using a smooth marble and a smooth plane and providing a lubricant on top of the planes. So you see frictional force acting on the marble, correct? When your ball came to the surface, right? So when does the frictional force act? Whenever two surfaces are in contact, then only a frictional force comes into picture. So for example, here also frictional force is your opposing force, right? Okay, so if you want to minimize this unbalanced forces, what do you have to do? You have to use a smooth plane. Right, for example, in your inclined plane also, when your marble was rolling down, along with gravity, there was also frictional force because your ball was in contact with this surface, right? Frictional force was acting in opposite direction, okay? So to avoid friction, what do you have to do? You have to use smooth surfaces, because in smooth surfaces, what will happen? There will be like contact surface will be minimized, right? So if you use lubricant makes the surface smooth, okay? On the top of the planes, what will happen? That friction can be minimized, and thus if your frictional force gets minimized, then your unbalanced forces get minimized. So let's study Newton's first law of motion. Let's get started. Newton further studied Galileo's ideas on forces and motion and presented 3 fundamental laws of motion. And one of them is Newton's first law. So what is Newton's first law about? So first law is about inertia. Okay. That a body tends to remain at rest if it is at rest, and it tends to be moving if it is moving. Right. Law we will study. An object remains in a state of rest or uniform motion in a straight line unless compelled to change that state by an applied force. In other words, all objects resist a change in their state of motion. In a qualitative way, the tendency of undisturbed objects to stay at rest or to keep moving with the same velocity is its inertia. So what is inertia? Simply, your body resists change, right? You want to stay at rest if you are at rest. If you want to stay at motion if you are in motion, correct? You want to, just resist change. You want to resist change. That is the inertia. So let's say that inertia has 2 types. One is inertia of rest and one is inertia of motion. We'll study in detail about this. illustrations of Newton's first law of motion. So have you ever seen this, that while traveling in a motor car, so for example, if a motor car is already moving, okay, a motor car is already in motion, what will happen? You'll see that you are pushed, and if suddenly brakes are applied, what happens is that you are suddenly pushed in the forward direction. But why does this happen? Because when your car was moving and you were inside the car and you were also moving with the car, right? Car is moving, you are also inside the car, you are also in motion, right? So your body is in motion because suddenly the brakes are applied. And what happens when suddenly brakes are applied? Your body tends to remain in motion, right? And suddenly brakes are applied, so your body wants to be in motion, so it is pulled forward, it is pushed forward, okay? You fall in the forward direction. Okay, why do you fall in the forward direction? Due to inertia of motion. We call it inertia of motion because your body is already in motion. Okay, and we see another case. For example, you just sat in a bus, okay, and your bus, initially it was at rest, and it started moving. So whenever your bus or your car starts moving, you'll see that you are pulled backwards. Why do you fall in the backward direction when it suddenly starts? Because your body is in rest, and your body tends to stay in the rest due to inertia of rest. Okay, so suddenly it starts moving. So what happens that you tend to fall backwards. Okay, this is all due to inertia, which is our first law of motion. So let's see one more illustration. If you're standing in a bus and the bus begins to move suddenly, you tend to fall backwards, right? This is because sudden start of the bus brings motion to the bus as well as to our feet in contact with the floor of the bus. But the rest of our body opposes the motion because of its inertia. So this is your inertia of rest. Because your body was at rest, and suddenly when it begins, your body tends to stay at rest. Okay. One more example, right? When a motor car makes a sharp turn at a high speed, we tend to get thrown to one side. This can be explained on the basis of law of inertia. We tend to continue in a straight line motion. When an unbalanced force is applied by the engine to change the direction of the object, right, we slip to one side of the seat due to inertia of our body. So let's do one activity to illustrate inertia. Make a pile of carom on a table. Attempt to hit a sharp hit at the bottom of the pile using the striker. So, okay, use the striker and give it a very strong hit. What will you observe? That the bottom coin moves out quickly. All other coins fall downwards and your bottom coin moves out quickly. Why so? This is also due to inertia. Because once the lowest coin is removed, the inertia of other coins makes them fall vertically on the table. Because what happens is that when you hit the coins from the striker, you gave the motion, right? They were initially they were at rest. So when you hit the coins with the striker, they are given a sudden motion, correct? So what happens that your motion, your downward coin gets into motion, but your, coins which are placed upwards, they tend to remain at rest. They are like opposing your motion. They are like, we want to stay at rest. Okay, these coins don't want to move. So what happens then? Then these coins eventually falls downwards, right? Due to inertia of rest. These coins were at rest and they tend to remain at rest. So, right? Correct. Due to the inertia of carom coins. Inertia of rest. Activity to illustrate inertia of rest. Let's do one more example. Take one glass, put a card on it and place a coin over it. What will happen? And now give it a hit, like from your fingers. So what did we observe? That when the card is flicked with finger, the coin placed over it falls in the tumbler due to its inertia. Right? So your coin is at rest presently, right? So when you flicker the card with your hand, so you are bringing the card into motion. Here both the things were at rest. Now you flicker the card and you bring the card into motion. But your coin tends to remain at rest, right? It wants to resist any change, right? Inertia is resisting change, right? So your coin wants to resist change. So eventually it will not go with the card when you flicker the card, but it will get inside the tumbler. Okay, it happens due to inertia of rest. Okay. So we studied about two conditions. One is inertia of rest. What is inertia of rest? That your body tends to remain at rest if it is at rest. And second is your inertia of motion, which means that your body tends to keep moving if it is already moving. Inertia and mass. There is a resistance offered by an object to change its state of motion. If it is at rest, it tends to remain at rest. If it is moving, it tends to keep moving. This property of an object is called as inertia. Okay, so let's see one beautiful example. For example, your cart is moving. Okay, cart and apples travel along with uniform motion. Okay, they are traveling. Suddenly there is an obstacle. There is a barrier. Okay, so it is trying to stop the cart. So what will happen? Both the things are in motion. Okay, so when the barrier comes in between, so your cart stops. Okay, but your apples, they are in inertia of motion because they were already moving, right? These things are apple and the cart is moving. Okay, so your apples were in inertia of motion and sudden break. They tend to resist any change. So due to inertia of motion, you will see that your apple continues to move forward. Your apples continue to move forward. Why? Because of inertia of motion. Let's see one more case. So for example, you see this car, okay? It is already in motion and this radio is also in motion with the car. So what will happen? That, if your car is suddenly stopped, if brakes are applied, then what will happen? That the radio, which is placed over the car, okay, it is in motion, right? You will see that when you suddenly apply brakes, this radio will fall downwards. Why so? It will tend to be in motion because it was already in motion. So you will see that when brakes are applied, your radio falls due to inertia of motion. It was in motion and it tends to remain at motion. Even when the brakes are applied in the car, your radio continues to resist any change and to be in motion. If we kick a football, it flies away. But if we kick a stone of the same size with equal force, it hardly moves. Why? Because, in comparison to football, the stone has a much lesser tendency to change its state of motion. So, accordingly, we say that the stone has more inertia than the football. Okay, so you'll see this. So, your mass is proportional to inertia. If you have a larger mass, like a very heavy object, you'll have greater inertia. Okay, and if you have a smaller mass, you'll have lesser inertia. Okay. Heavier or massive objects offer a larger inertia. Quantitatively, the inertia of an object is measured by its mass. We may thus relate inertia and mass as follows. Inertia is a natural tendency of an object to resist a change in its state of motion or of rest. So the mass of an object is a measure of its inertia. Let's do this question. A rubber ball and a stone of the same size, which of the following has more inertia? So you tell me. You have both the things of the same size. Which one is heavier? What do you think? So we see that, the mass of the rubber ball is more, mass of stone is more. If they both are of the same size, of course, your mass of stone is more. So if the mass of stone is more, so it will have greater inertia because we know that mass is proportional to inertia. So in our A part, which has more inertia? Stone. Okay. A bicycle and a train. You tell me which one is heavier? Train, of course. So train has greater inertia. Third, a 5 rupee coin and a 1 rupee coin. So have you seen the difference? Like, 1 rupee coin is a very, thin and sleek one, right? And a 5 rupee coin is like very thick. It has some breadth, okay? This is your 5 rupee coin. So of course, your 5 rupee coin is heavier than your 1 rupee coin. If you think that, it is not so, take the coins in your hand and check it for yourself, right? So your 5 rupee coin will have greater inertia because it is heavier. Remember, this thing, mass is proportional to inertia. If your mass is greater, your inertia is also greater. Okay. Let's do one more question. In a following example, try to identify the number of times the velocity of the ball changes. A football player kicks a football to another player of his team. Let's say player 1 and player 2. Who kicks the football towards the goal. This is your goal, okay? And he kicks the football to the goal, okay? Now the goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. Now this player, this is the goalkeeper. He's saying, okay, you wanna hit it? I'll not let you hit the goal. So he stops the ball. And after stopping, this is your goalkeeper. And after stopping the ball, he kicks it towards a player of his own team. Okay. Now the goalkeeper and kicks it towards a player of it's his own team. Okay. So we have to see that how many times the force changes. Okay. The velocity of the ball changes. And identify the agents applying the force in each case. So firstly, this player 1 is, kicking the ball towards player 2. Here your velocity, for the very first time, this is kicking the ball, okay? So it does it with some velocity, right? Then your player 2 receives the ball and it kicks it again towards the goal. Again your velocity changes, okay? Now your goalkeeper stops the ball. When your goalkeeper stops the ball, then also your velocity changes, right? It decreases and the goalkeeper brings the velocity of the ball to 0 to stop the ball, right? For the third time. And for the fourth time, the goalkeeper again kicks the ball towards his own team member, right? For the fourth time. So what do we see? That how many times the velocity of the ball changes? It changes for 4 times. And identify the agents applying the force in each case. So our agent 1 is player 1. Player 1. Who is our agent 2? Player 2. Your agent 2 is also, your player 2 is also kicking the ball, right? And changing the velocity of the ball. Who is your agent 3? The goalkeeper who stops the ball. And who is your agent 4? Again, goalkeeper. When he kicks the ball towards the player of his own team. So your velocity is changing for 4 times and these are your required agents. So let's do this question. Why some of the leaves may get detached from a tree if we vigorously shake its branch? This is your tree. It is at rest. Okay. And you start shaking the branches of the tree. What will happen? Your branches will come in motion, but your leaves tend to remain at rest. Why? Due to inertia of rest. They're suddenly, brought into motion. So that's why the leaves get detached. So let's read this. Some of the leaves may get detached from a tree if we vigorously shake its branch, because when we shake its branch, the branches come into motion, but leaves tend to remain at rest due to inertia of rest and oppose the motion of the tree, right? So the leaves get detached. Okay. Let's do this question. So we have answered this earlier also. Why do you fall in forward direction when a moving bus brakes? So of course, when it is your moving bus, you are also moving, you are sitting inside the bus, so you are also in motion, right? So when suddenly brakes are applied, you tend to move in the forward direction due to inertia of motion, right? Right. So let's write first. You tend to fall in forward direction when moving bus stops suddenly by due to inertia of motion. Your body tends to remain in motion. It resists any change. Second case, and fall backwards when it accelerates from rest. So what happens, right? Your body tend to fall backwards when bus accelerates from rest. Why? Because your body is initially at rest and it tends to remain at inertia of rest due to inertia of rest. Okay. So thank you so much. We'll meet in the next video and study about Newton's second law of motion. Till then, revise. And again, let's do a quick recap of today. We studied about laws of motion. We studied about Galileo Galilei and Isaac Newton's approach and how, frictional force acts. How we studied about three cases. First case, when force is less than frictional force. Second case, when your force is equal to frictional force, which was your balanced force, right? Because opposite and equal forces, right? This is your balanced force. Third, when your force is greater than your frictional force. This is your unbalanced forces. So first and third are your unbalanced forces and your second one is your balanced force. And then we studied about Newton's first law of motion in detail. So what is inertia? A body tends to remain at rest if it is in rest and tends to keep moving if it is in motion. Okay. So we'll meet in the next video with Newton's second law of motion. Till then, do revise, and if you have any doubts, feel free to ask. Bye-bye.